Okay, so first of all, do you agree that cosine of t squared cannot be integrated? U sub is a no-go because there's no du to go. So let's use series. What is the series for a cosine? First three. 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, okay? Cosine of then t squared, actually let's just start now writing this into the integral. Cosine of t squared, that means substituting t squared in for every x. So 1 stays 1, but what does x squared over 2 factorial become when substituting in t squared? T to the fourth over 2 factorial. What does x to the fourth over 4 factorial become? T to the 8 over 4 factorial. If I were so inclined, what is the general term? Negative 1 to the, let's go here. What's the general term for study purposes of the cosine function? X to the 2n over 2n factorial, and n starts at 0. So to start at positive, do I go negative 1 to the n or n plus 1? N. Okay. So that said, we're integrating, or we're subbing in t squared. So it's negative 1 to the n, t to the 4n over 2n factorial. And integrating with respect to t. All right? Now let's integrate, shall we? The antiderivative is something like t minus t to the fifth over 5 times 2 factorial plus t to the ninth over 9 times 4 factorial. Talk to me about the general term. Does the negative 1 to the n stay the same or change? Stays the same. Does the 2n factorial change or stay the same? Stays the same. What about the t to the 4n? What's the antiderivative of t to the 4n? T to the 4n plus 1 over 4n plus 1. That's the power rule for integration. From, so on and so on, from 0 to 1. Now, when 0 goes in, because every term has a t in it, that will be a non-issue. So when 1 goes in, it amounts to 1 minus 1 over 5 times 2 factorial plus 1 over 9 times 4 factorial, and so on. Now, I didn't put it in the question, but you can imagine the possibility of saying, estimate this integral with an error less than, if it had been estimate with error less than 100. Are we talking Lagrange here or alternating? It is alternating. Do terms decrease in absolute value to 0? They do. And so because it's alternating, terms go to 0 and decrease, it is the case that s minus s sub n would be less than the next term. So what is the first term you see that would be less than 100? Because obviously it's not the first or the second. Is the third less than 100? Yes, okay. So we would estimate with S2. S2, this integral from 0 to 1 of cosine of t squared can be estimated by S2, which is 1 minus a 10th over 0.9. We could say the error is less than 100 because s minus s2 is less than or equal to a3, which is what we got there, 24 times 9, 180, 216, 1 over 216, which is less than 100. You with me? Are you with me? Yeah. Okay. Now then, this is pretty cool because this is often how calculators or programs are written to find pi. Obviously, They don't find pi old school style where they would actually take a string or some kind of bendable measurement tool and measure the distance across, measure the distance around, and divide, which is how they used to calculate pi. It's the ratio, pi is defined as the ratio of the circumference to the diameter. We can find pi a little different. So let's say you give me the equation for the unit circle, people. What is it? X squared plus y squared equals 1. Now, could we not say that the area inside this baby is pi r squared, or pi times 1 or pi? Okay? The area of the unit circle is pi. Now let's look at this in a calculus-y kind of way. First of all, top half or bottom half? Top half. Whole top half or just the right top half? Right top half. So wouldn't you agree that the integral from 0 to 1 of 1 minus x squared is equal to blank? What is that equal to? Pi over 4. All right. Pi over 4 is equal to that. All right. Now, we could estimate that bad boy with a little series action. Yeah, this is a binomial series, right? So this is like this series 1 plus negative x squared to the half. All right. Now, I know my binomial series by now because it's coming on the text. How would the binomial series start? First term is 1 plus. First derivative is 1/2, and then it's x to the first over 1 factorial normally, but in this case not x, but negative x squared. Then the next derivative is 1/2 and negative 1/2, x to the second normally over 2 factorial, but again, instead of x, we're substituting in negative x squared. Let's start with 3 for now and call that good. Do a little cleanup or no roll? Go for it? Okay, what's the antiderivative of 1? X. All right. Now that's a negative to the first power, which is negative. So the negative will stay, the half will stay, the 1 factorial I'll dump. What's x squared? Yes, sir.
On the test, do you want us to show the first power and then 1 factorial? Or can we just say 1?
I wouldn't count off if you did put 1 factorial there. So what is the antiderivative of x squared? 1/3 x cubed. So x cubed over 3. Okay. The next coefficient, how does it all pan out? First of all, that negative x squared, is it positive or negative? It's positive, but I also have another negative there, so this will feels like it's going to be negative to me. Numerical coefficient, what is it after all is said and done? 1/8 x to the, now it was x to the 4th, the antiderivative of which is x to the 5th over 5, yeah? All right, we could keep going. We'll just say from 0 to 1. Again, this is a nice case where the 0 is a non-issue, so we can just focus on the 1. So it feels like we get 1 minus 1/6 minus 1/40, and that to me sounds like it's okay. That is, what's the common denominator, people? 120, maybe. What do you think? Okay, so 120, that's 120 minus 20 minus 3, or 97 over 120, eh? That's now, remember, pi over 4. So pi then is roughly 97 over 30. How do we do? What's 97 over 30? feels like that's more like 3.2-ish. It's a little much, but we'll see. So we got 3.23. That's ish. Well, we didn't work very hard. We only did 3 terms. We could do another term, and we would get better, obviously, and better and better. All right, you with me? Okay. Let's say we go about this a different way. There are actually a couple different ways to use. And this is a beauty. This is how your calculator can calculate our tangent here. So, this is the thought process. What is 1 over 1 minus x is series? 1 plus x plus so on. Okay, now you're trying to get to our tangent. How do you reckon we get there from 1 over 1 minus x? Change that to 1 over 1 minus negative x squared, yeah? So if I substitute in a negative x squared, that's 1 minus x squared plus x to the 4th minus x to the 6th. That then is negative x squared to the nth. Oui. Now that is the same as 1 over 1 plus x squared. Wouldn't you agree? So how do you reckon we get to our tangent? The antiderivative, yeah. The antiderivative of 1 over 1 plus x squared is, now let's talk about the goal. The goal is to estimate pi, not to estimate or find our tangent. So what definite interval could we use to estimate pi? What do you reckon we should be looking at? Inverse tangent of 1 is pi over 4. Okay, so, and then we would also like the other limit to go bye-bye. So what else should we use besides? 0. We're going to go 0 to 1. And that'll get us pi over 4, I'm thinking, and then we'll deal with the 4 later. You'll follow me, people? Yes. All righty then. So that means I'm going to integrate both sides. Can't just integrate one side. Got to integrate both sides. Like that. 3x. So, what is ye old antiderivative? X minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. Our tangent looks like it's got a lot of odd powers. Why does that make sense? Because our tangent is an odd function. That makes sense. I'm feeling like negative 1 to the n. If I squish that out, and it's x to the 2n plus 1 over 2n plus 1 for the general term. You see where I'm coming from? I didn't want to run the power rule on both of that stuff. I separated it into negative and the x. Okay, so at 1, the series becomes 1 minus a 3rd plus a 5th minus a 7th plus a 9th minus an 11th, and that represents pi over 4, right? Do you agree? Okay, now then, pi could be approximated by 4 minus 4 thirds plus 4 fifths minus 4 sevenths plus 4 ninths minus 4 elevenths. Now this one converges much faster, and therefore is the one that's typically used for the program. Give it a go. See how close you get as you add more terms. I'm just building off the answer each time. Actually, is there one that converges faster? I can't remember if there's one that says that converges even faster than this. It's converging pretty slow, I gotta say.
What would you give me this one? I've gone all the way up to the 7, then I'm at 2.7.
Yeah, it's 2.78?
Yeah.
Oh no, I'm at the 15.
Oh wait, I messed something up.
Yeah, I'm at in the 3-ish range. 17. Yeah, it's converging pretty slow. We still a tenth off even after the 17th or 17th denominator 17. There must be a quicker way. Maybe this isn't what they use. I think they use something that converges faster. That's pretty tedious. Okay, but anyway, you could, with enough terms, gradually start to converge on pi. And the arctangent series, that might come in handy. You might write that down and box it. Save you some work later. The arctangent series is x minus x cubed over 3. General term negative 1 to the n, x to the 2n plus 1 over 2n plus 1. Okay, that is pretty much all the series stuff, but a couple little exceptions. You got to do a little differential equation with series. There's a little here and there I got to add on top of Saxon, but we pretty much are done with series, pretty much. All right, are we cool? All righty then. This is last year's notes. I did not need those. Okay. So, would you, we did that. Oh, here's the, I can't remember where we were at with 144, 45 extra practice questions. You're on the free response. Did we start the free response? Jeff started. Cool. Here we go then. Yeah, 5 minutes. All right. How did the old ratio test go? Did you get, let me get my key out. Did you get an infinite or all reals kind of interval? You did not get all reals, so we should go over that. Okay. Here we go. There it is. Oh, no, not all reals. Sorry, negative 1 to 1 inclusive. How's that sound?
Which one's inclusive?
Both. No, so we don't agree. Shall we pick up with the endpoints, or do you want to go back to the very beginning and do the whole interval? Just the endpoints?
Yeah.
Okay, so where our series here is this. I'm going to write it here in case I scroll. 2n plus 1 over 2n plus 3. Our interval is negative 1 to 1, and now we're checking the endpoints. Here we go. When here's, just make sure that your reader can figure out or follow what you're doing. Hey, reader guy, I'm saying when x is negative 1, this is what happens. Negative 1 to the n stays. Negative 1 to the 2n plus 1 over 2n plus 3. Now, it's up to you how you approach this. Some people work in the summation notation and try and clean it up in there. Some people prefer to just make a few terms and say, what the heck is going on? I feel like this will alternate, yeah? Do you agree? But this is 2n plus 1 is always going to be odd, and so because it's negative 1 to an always odd, this will always be alternating. This part here will always be negative, and overall then it will be alternating, okay? So, if you could see that without making terms, great, but you could say that this is something like an alternating series. The terms go to 0 and they decrease. Now your question, maybe your question, especially for those super high level of you, is I'm proving conditional, right? Do you agree? And when I taught you conditional convergence, I made you first prove that it didn't converge absolutely. And that's by the book. I mean, that's how you're supposed to do a conditional convergence proof, is first prove it's not. So the thing though is, in looking at every AP rubric I've ever seen, they never said or took the time to prove it wasn't absolute. So I guess for AP purposes, if you just went here, great. But for college purposes, I would say something like not absolutely converging because this compares to harmonic. I think that would cover your tush with just about everybody. But for AP purposes, I don't think, I know you don't even have to say that one. Okay, so wouldn't you agree that this converges conditionally at -1? What about at positive? Now let's get into that. If I put in positive 1, that's -1 to the n, 1 to the 2n plus 1. Obviously, that is just 1 every time. And so is this alternating harmonic? It's not harmonic, actually. You would probably lose points if you called it harmonic because it's not harmonic. But this is alternating series. You could actually say same as x equal -1. It's alternating. Limit of the terms is 0 and decreasing. So it is converging at the right endpoint, and that's where I'm getting an in. Answer of -1 to 1 inclusive of both. Are we down? Sorry I don't have the rubric at the ready. I can't remember what year I pulled this from. 2, or B rather. How did the old B go? Great? Bad? Okay. The Maclaurin series for G evaluated, is that what that series is? Oh, the function G, that's the Maclaurin for G, evaluated at half, blah, 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 blue. The approximation is, wow, they're doing everything for you. What do they want me to do? All they want me to talk is error bound, yeah? Okay, so wouldn't you agree that because it's alternating series error bound, the true value of G of a half and the Maclaurin of second degree? No, sorry. Darn it.
Wait, did you talk through it that way, or like through it?
You could just say S minus S. Yeah, you didn't have to do it this way. You could just say the true sum minus S2 is less than or equal to A3. Can I get this today, please? Sure. A3 is 1/2 to the 5th over 7, which is 1 over 224, and that is less than 1/200. Okay?
Yo, I don't know, dude.
This one?
Yeah, but no, I'm talking about
Yeah, attendance and sequence
well, I don't know if like you able to tell that.
Is it from the exponent itself, or it was to the one? No, it was positive exponent.
Well, I mean, she would. It's not like she like cares, but she'd be like, Alex, why did you?
This is the last.
Do you have a tracker on your phone?
Tangent square to
What?
secant
Do you
square.
have a tracker? Oh, you know it. Sure, yeah, can you just say go ahead?
Yes.
What would you do if I was a complete idiot and finished 145 and just didn't turn it in?
I'd probably cut you some slack because I haven't graded you, and I'm also a pretty good. Good luck. I didn't see the show.
I just brought out the set during the past period to work more on it, and it's just like, there's 145, and I'm just like, how's that?
It's going fast.
So how many times did we use? Oh, Q110 was the third degree, so we should be talking fourth degree. So I use that for why 442? Oh, was that? Oh, I. 142. Right, it's just 645 there. Because you don't know sine of whatever variable, I would just use sine is less than 1, so the whole thing is less than 625 times 1. So you should use it in 625. Yes? would just take the derivative on that. That stays the same. That stays the same, and the derivative on that is 2n plus 1 comes down, x to the 2n. So it's easiest to, you could find the derivative from your pattern, but it's just as easy to take the derivative on down. Okay, one to the other.
Calculus is what's gonna make us all happy again.
What's arc tangent of 0?
So just really good.
Tangent of 0 would be 0, right?
I'm sorry. Oh. I'm sorry.
All right, I need to hand out some handouts, which is why they call them handouts.
Whoa. Oh. Gonna leave that.
Oh, goodness.
Are you having a good day?
I am running on empty here. I'm kind of just struggling to the finish line.
But calculus is gonna invigorate.
That's true. Your unit passion for calculus is going to get me going. Why do I have so many absences? Are there that many people in chat? Emma's on track. She is on track. Nathan would never join track. He needs to.
Very loud.
Really? You thinking about smoothly?
So there's these two different items you missed early, so I can get this missed now, but I can't miss now. So is it okay if I leave fast if you miss early?
Sure. Yeah.
Yeah, if this is Scott, we're gonna get like hours. It's good.
Mine says cinnamon.
It's only 1 week, it's not even
Yeah.
What a great way to end like all lessons and stuff, like
She realized. Have a good day. I thought she had it already. Well, it's like sometimes senior year stuff. Oh, there you are. You're welcome. All right. Hi, people. All right. So did you do the AP? You saved the AP from yesterday for a warm-up today, yes?
Yeah.
Okay, you already did it, complete work on tonight's homework, but that was the intention that you would use the back of 147 AP problem as a warm-up today. I totally screwed it up myself the first time, so I'm going to redo it this time. But it's not that hard, I just need to really know. You can do it. I know. Hey. I refuse to acknowledge you.
So for A,
What does that say? Yeah, substitute away A.
But do we change the center so it's
No, you're not changing the center. I want chlorine.
So it's McLaurin for F.
Yeah,
We're gonna have to use her for zero.
yeah.
We have to change it.
No, it was McLaurin before. It says right there, the McLaurin for log 1 plus x is this, right? Another McLaurin, yeah. Don't overthink it, Nathan. The first one's easy.
We just need to change the order, right? We wouldn't substitute 1 plus X. Substitute X.
It's okay.
It's making physically amazing sense.
No, it's not the problem.
Say yes. Tells you what to do.
Yeah, but I don't know how to do it.
I don't know how to understand this weird form language.
First four non-zero terms of f prime of t squared.
What are the two?
So what two things you gotta do there?
Cry. So you.
What two things do you have to do there? F prime of t squared. F primes, so the derivative of the series, and substituting t squared. The only question is, do you do the derivative first, then put t squared, or put t squared in, then take the derivative?
That's a question.
That's the question, yes.
Yeah.
So what do you think? You understand what I'm talking about so far?
Sure.
Okay, so you have a series for f, yeah? That was part A. You did part A, yes?
Yes.
Okay. And then part C starts by saying, give me a series for f prime of t squared. Now, obviously, then in terms of changes, that means there's two changes, a derivative and a t squared going in. Your next order of business is then to say, well, which should I do first? Should I find f prime then put t squared in that? Or should I put t squared in, then take the derivative? Yeah, why is this better? Right. If you did this first, then when you took the derivative, what would have to happen? You've got a chain rule. So that tends to lead to mistakes. You took a derivative, you got this extra 2t. So I would suggest this approach. What's the series for f prime? Then put t squared into the series for f prime. Then do g. So it's really 3 steps. Be done in 2 minutes. While I get a cup up. 3 minutes.
I know, it goes, it goes way up, right?
So you find the amount integral of
Interval crossing. Me neither.
Wait, so what did you get for your G? Like an inverse series.
X to the 6th minus X to the 12th plus X to the 18th.
Where do you get your X minus 2 squared? I walk for you. Every Sunday.
I didn't know it was that serious. I thought you shut up.
I did. I don't think I would have she was second.
Yeah, I got it.
Like a fraction.
Letters on.
It's almost like down. The big one. The big one.
Well, yeah, I got 6 over 2, so I was
Oh. What are you doing random?
No idea.
Oh.
Oh, okay. Alright, fine. Let's do some math. Just a second, okay?
Anyway.
Are you ready to get a 9? Okay, this is the low point, obviously. You'll get better and better at these. And you really, I think you'll go into the AP test thinking if they don't get me too crazy, I'll get a 9 on this. Hi, Mr. Murphy.
I felt this waft of hot cocoa.
Yeah, you want some?
No, I was just wondering if I smelled that right.
Oh no, it's just our math department coffee machine.
You've got a huge class.
I'm missing. It's always small, but I'm missing 2.
Well,
Yeah.
this class is just
Doesn't-
keep their little secret what Dawson teaching.
Oh.
Kids can use support.
There's not many people that can handle this level, I tell you. All right, are you ready? So the rubric looks like this, my young whippersnappers.
He's on the exact opposite side of the school where he's supposed to be right now.
Isn't he teaching right now? Is he teaching right now?
Not sure.
Okay.
6th period, he has drama class.
Does he really?
Yeah.
Oh.
Why is he over here?
No, I don't know. Did you get the first 4 terms? X cubed minus x to the 6th over 2 plus x to the 9th over 3 minus x to the 12th over 4. First point earned. Check. +1. Did you get the general term? -1 to the n plus 1. If you didn't put parentheses around that, you would not get that point. X to the 3n over n. Very good?
Yeah.
I don't know if they're super picky about that. It continues after. But I can tell you I had a professor that was total crazy about that. It's not a terminating term. It goes forever. And so you should always make sure that you have an infinite series with an ending ... Okay?
You didn't even have to do the ratio test.
No, they gave it to you, silly goose. Why? Okay. Well then, they gave you that it was interval of convergence was 1. So that tells you know it's between -1 and 1. I think that was the intention that you start there, but if you wanted to crazily overachieve, we're good.
Wait, I'm an overachiever.
No, that's just being ridiculous and silly. Okay, so you can see that they are actually showing some terms. Some people like that. Some people like to actually see the terms. Some people would prefer to, in the summation, plug in -1 to the 3n and go from there. Either, sorry, when I'm looking at -1. But either way, you need to get a feel for the series. Did you understand that it was a harmonic series with negatives in there? Okay, so when x is -1, it's a harmonic. It would not be enough if you just said diverged. That would not get the point. You have to explain why you say it diverges. Diverges, harmonic. Otherwise, nothing for that endpoint. Okay? You must explain. It's not a 50-50 shot. You can imagine they're not going to give you a credit for guessing right and saying, yeah, I'll include it. No, you must say why or why not. And if you don't, then you're wasting your time at all. All right. If you then, how do I get rid of this thing? I'll just stash it over here. There's some writings over here for my enjoyment. All right. What about at positive 1? Did you get that it was an alternating harmonic? Now, they are going, apparently this is the College Board's work, so this apparently saying alternating harmonic series converges is enough. I wrote that and I thought, what if they're being crazy this year? So I then said, it's an alternating series with the terms decreasing, absolute value 0. But either way, it's inclusive of the right, is the idea. So if you said no on the negative 1 with justification and yes on the positive 1 with justification, then give yourself 2. Otherwise, feel the shame.
What if we did very little justification?
What did you give?
I got just the right answer.
Oh, then that you get a 0. No justification is a 0. All right. Questions? Okay. For C, you had to first deal with, now they didn't start giving points till the second step, but here, we talked just a second ago about what should have gone through your head is, all right, I need to build a series incorporating a derivative and t squared. The second thing that should go through your head is, in what order should I do those changes? Doing too much at once is disastrous, okay? So, you could have sub t squared, then taking the derivative. But doggone it, if you do that, you better make darn sure you're using the chain rule there, and you've got two t's there. It's safer to go f prime than f prime with t squared, all right? That's what they did. They said f prime is cha-cha-cha, you get a bunch of 3's. F prime at t squared then is this. What if you wrote the series with, instead of t's, you wrote x's? Are you good? No, you're bad. You lose. It's t is the variable, not x. And they're not interchangeable. It is what it is. So you needed t's in there. So this is what you should be looking at in terms of points. If you have, of these 4 terms, if you have 2 of them, then you get a point. And if you have the other 2 of them, you get a second point. Okay? After that, then G involves anti-differentiating. So G should be 3x to the 5th over 5 minus 3x to the 11th over 11. The other guys you don't really need. Although if you read ahead in the problem, if you read the whole problem, you might have said, oh, I might need another one for an error bound. So I'm usually in the habit of, if I read ahead and see that I'm going to need an error bound, I'll do another term after what they say. I don't know why they did the 4th term, just consistency, I guess. But then G at 1 involves putting 1 into the first 2 terms. So your estimate, did you get 18 over 55?
Yeah.
I didn't. I can't add fractions. I got something else. I got 420s or something. What did I get? No, not 4. I got 4 11s. Why did I get 4 11s?
3/5 minus 3 11.
So you multiply this. Oh, that's 33, not 35. I'm stupid. Kind of late. What the heck? I just took an 8 because I can't add fractions. D. Now, I told you this before, and I'll tell you again. Sometimes they meet the conditions for alternating series for you. Sometimes you have to meet them. They said in the question, they're meeting the conditions. You never use alternating series error bound unless the conditions are met. They told you it was an alternating series with individual terms that decrease in absolute value to 0. That's the word phrase for alternating. Limit of the terms is 0 and decreasing. So they're saying the conditions for error bound are met. You do not have to state them. you can go straight to the difference between, most of the students in the last class said S minus S2. That's fine. If you have S minus S2 in here is less than A3, no problem. A3 then is 3/17 once you put 1 in for X, and that is indeed less than 1/5 because 3/17 is less than 3/50, which is 1/5. Right? How do we do? Do we get a niner? Niner?
I
8?
got a
2? 2? 2? What'd you get?
I goofed up the first, but I got did
The
all,
first one was the easiest one.
but I did all the other ones right with the work that I did in the first one. So I think I
So you would have get carried through. Jeez Louise, Claire, what'd you get? 8, 7? 7? That's fine. Okay, that's all, I can go to 7. If you're at 7 at this stage, you're in really good shape. You should be at 7. Okay? Julia? Okay, never mind, I forget I just said your name, Julia. All right, here we go. I asked like 8 people before you. All right, notes. Do we want to hit notes? Do you have notes? Did I give you notes?
yeah.
Okay.
What? No. Can we talk about the extra practice?
This is the last big idea series, but there is an idea or two that I need to make sure you're solid on that's not in the textbook. So I can't promise you it's the last notes, but it's the last problem set notes. Here we go. The lesson of the day is how can you use series to estimate integrals? And that is pretty great. And it goes something like, have I been recording this? Oh, I've been recording